This is Coach Hyde, hydescience.org. Working through another density video today. In this video here, we're going to be solving for volume. The most detailed video of the series is the one solving for mass. So if you're still struggling with this a little bit, check out my video, the Hyde Science video on solving for mass using the density, and it goes in pretty good detail, more detail than this one will, or more detail than the density one will. All right, so we're just going to kind of jump right into it. The way we do it is we're going to rearrange this formula first so that it's what we're looking for. In this case, volume is on the side of the equal sign by itself. After we do that, we're just going to plug in, then we're going to solve. So first up, we're trying to find volume. In order to do so, we need to rearrange this formula so that volume is on the side by itself. So I'm just going to kind of rewrite this real quick. So we got density. We got a little equal sign right here. And then we got mass divided by volume. The most common mistake that I see when I'm grading papers, when I'm working with students, when we're working things out on the board together or whatever it is that we want to move this M away. Right? You want to move the mass because we want the volume to be by itself. All right, well, there's a problem with that. You can't move the mass away. That gives us some problems mathematically. Just like we said earlier, we're going to focus on doing the inverse or doing the opposite action of what is already here. So here we are dividing. We're going mass dividing by volume. The only move I have left, or only move I have that I can make, is to multiply this by volume. If I multiply this by volume, if I do it to one side, got to do it to the other side too. So on this side, we'll do V over here as well. And then, of course, we know from our rules that if I get two things on the same side, and they're identical on top and bottom. So we have a volume in the numerator, volume in the denominator. So that means we can cancel these out. So now we have moved the V from this side of the equation over to this side of the equation. And what we got now, I'm just going to rewrite it to kind of stay organized. So now we are at V, which is volume, times density equals mass. So if we were solving for mass, we'd stop right here and we'd plug in and go. But this did not get volume on the side by itself. It does not get our V by itself. So we got to keep rolling. So what we're going to do here is the same thing. We can only do the opposite of what is there. So we need to move the D. We have multiplication here between V and D. Right? So this is, I got it written next to each other. This is V times D. So with multiplication, it doesn't matter the order, right? 2 times 3 is 6. 3 times 2 is 6. So we can move either one of these by dividing. We don't want to move the volume back to this side, right? That would put the V back with the M. It wouldn't make much sense, right? It would be back where we started. We want to move the density away. So we're going to divide both sides, right? Because whatever we do to this side, we got to do to this side. We're going to divide it there. So now what we got, we're going to rewrite it. Now we have V equals mass divided by density. And I'll drop my marker. Mass divided by density. Now, if we look at this, if we split the equation through the equal sign, now the volume is alone. It's by itself on one side of the equal sign. That's what we want because we're trying to find our volume. So now we are ready to plug in and solve. So we're going to plug in a number for our mass. We're going to plug in a number for our density. We look at our two numbers here, so we're trying to find the volume with these two numbers. We look at these units here, and that tells us which one to use. This one has grams and centimeters cubed. So it has grams, right, is a unit for mass. Centimeters cubed is a unit for volume. So this has both the mass and the volume unit. So this is going to be a density. So we're going to take this 3 grams per centimeters cubed. We're going to put this in the place of our density on the bottom. So it's going to be 3 grams per centimeters cubed. Right? And then this other number, right, it should not be a centimeter cube. Right? Sorry, I do all this in one take, so I screwed up right there. Anyway, this is supposed to be 90 grams. We need the grams so we can put it in for the mass. So we're going to erase this mass here. This is going to be 90 grams. Okay, now it's all that's left is to solve. So if we solve this, 90 grams, right? And 3 grams on the bottom. Again, we have the same thing there. We have identified it on the top of the numerator and the bottom. So we're going to cancel these out. Our units are going to be centimeters cubed. So now 90 divided by 3, we have a big number divided by 3, big number divided by a small number. So this is going to give us a number greater than 1. So 90 divided by 3, 30. Our unit is right there, centimeters cubed. So we started with our equation, right? Our first step was to multiply both sides by the v. This left us with v times d equals m. If we were solving for mass, we'd be ready to go. One step, that's all it took. But we're going to have to do another step on this one to move that d across so that we get volume on the side by itself. So it's a little bit more time consuming. We've got to do one more additional step than we normally have to do when solving for mass. That's it. We get to that point, we're done. All right, so let me know if you need anything else with density. This is going to conclude the 3-part density series. We got one video on just solving for density. We got a video on mass, and I got a video on finding the volume.